Hi folks, today I have another LCD driver to show you. This time it is the NEC uPD16431. This driver supports up to 224 segments. However, if we decide to use the pins that provide the LED output function, the available number of LCD segments is reduced to 192. That is because we lose 4 groups of 8 LED ports, one group for each COM line. In this project, we will use the maximum segment configuration. This is also the default configuration after the driver is initialized, even though the display we are using only has active segments up to 3/4 position. The driver's manual is not exactly perfect. Even so, it contains all the information needed to bring this device to life. One important detail is that data is transmitted starting with the MSB, the most significant bit. For that reason, the binary words used in the code are constructed in reverse order. Of course, another approach would be to reverse the transmission routine itself, instead of reversing every binary value. Looking at the pin description, we find another important detail. Data is written into the driver on the rising edge of the clock signal, while key scanning takes place on the falling edge. The driver supports a 4x8 keyboard matrix, allowing up to 32 keys. Even more interesting, it provides a dedicated key rack output pin that acts as an interrupt or trigger whenever a key is pressed. This means we only need to read the keyboard when the key rack signal goes high, making the implementation much more efficient. Since this LCD uses 4 common lines, the required bias voltages are generated through 4 intermediate voltage levels using the pins VEE, VLC3, VLC2, VLC1, and VLCD. The datasheet specifically recommends connecting VEE directly to VSS. The driver allows either an external resistor divider or its internal voltage divider to generate these bias levels. One interesting point is that the datasheet recommends a VLCD supply voltage of 6 volts. However, on the panel we are using, VLCD is connected directly to 5 volts DC. Communication with the driver uses the following signals: data, clock, strobe, and OE. If you also want to implement a keyboard, you can make use of the key rack pin together with an interrupt routine. Although the keyboard is not used in this demonstration, the reading function is already included in the example code. To enable it, simply remove the command markers. The command set of this driver is surprisingly simple. Only 2 commands are required: the display setting command and the status command. When writing display data, each transfer consists of 7 bytes. Each individual bit controls 1 segment. 0 means the segment is off, 1 means the segment is on. Since 7 bytes correspond to 56 bits, and the driver supports up to 224 segments, we need to transmit 4 separate data blocks to update the entire display. The block selection is defined by bits B3 and B4 of the status command. The keyboard reading process is also configured through the status command. The driver returns 4 bytes. representing the complete 4x8 keyboard matrix. Once the relationship between each bit and its corresponding segment has been identified, we gain complete control over the display. For this demonstration, only the 8 14-segment alphanumeric digits have been fully mapped. As is common with many car radio displays, there are separate power supplies for the logic circuitry and for the backlight and LED illumination. On this panel, there are 2 dedicated power inputs for that purpose. You can think of them as the dashboard illumination and the radio illumination when the unit is switched on. With these details in hand, it becomes quite straightforward to bring virtually any display based on the uPD16431 driver back to life.